let g be a twice differentiable function. One of these graphs is the graph of g, one is of g prime, and one is of g double prime. Choose the option that matches each function with its appropriate graph. Okay, so let's start with the first one. Here, let's think of the gradient of this function, of this graph. So as you can see from this point, let's say this is the turning point, we go towards the left, and we go to the left. If it is moving downwards, then it will be positive gradient. So for this portion, we would expect something above the x-axis for the derivative of this function. Is there any function? Yes, it is. This function matches this portion, and this also matches this portion. So the derivative of this portion of this point is 0. The tangent is parallel to x-axis, so we must have 0 here. Do we have 1? We have here. What about this? Roughly speaking, so it's 1, 2, 2.5 units there. So it's not 2.5. So it doesn't match that way. Also, that you have a turning point here. It shouldn't be below the x-axis before this point, because it is positive entire. So this doesn't match actually. This matches as the derivative of this function. Let's see whether it is consistent up until this point or not. So then if we move right, if it goes downwards, then it's negative gradient, and as you can see it's negative gradient. It will be negative until this point. Okay, we're moving right, it's going down until this point where it is 0. So it's just before this point. So just before this point it's 0, and again when you move right, it's going upwards, so it's positive. So this matches exactly. So we could say that the serial is 1 followed by 2, which means the second graph is indeed a derivative of the first one. And the question is, what about third? Will the third function be here or here? Okay, let's try this one. Let's see whether this function is the derivative of this function or not. So for this portion here, we need 0. We need a 0 right in between this and this. So do we have 0? We do have 0. Okay. So if we move left, it is moving upwards from this point, which is a negative gradient. Okay, so the derivative should be below x-axis for this, before this this point from the left. So is it on the negative side? Yes, it is. Okay, as it is moving right sides, as we go right side, we see the graph is approaching, moving upwards. So it's a positive gradient up until this point. So up until this point where it should be 0, it is 0. The graph is indeed positive, so it matches. And from here, if we move right, it is moving towards downwards, so it should be negative after this point. So it is indeed negative, and it should be negative throughout. So after this is 0, this is okay, but the curve doesn't take any more turns. So as we move right, it is moving downwards. So because it is moving downwards, the gradient is negative. The gradient is negative up until this point. Still, it's negative. So it should be below x-axis after this point. After this point, everything should be below x-axis because we have negative gradient. Okay, from this point, if we go left, we go up, as you can see, and if we go right, we go down, negative gradient. So is the graph negative entirely? No. Yeah, it is. It is entirely. below. So basically this matches our findings. So the serial is 3, 1 and 2. So 3, 1 and 2 matches with option D. Let's try option D. And that is the correct answer.